Observational study. Researchers wanted to determine the long-term benefits of the influenza vaccine on seniors aged 65 years and older. The researchers looked at records of over 36,000 seniors for 10 years. The seniors were divided into two groups. Group 1 were seniors who chose to get a flu vaccination shot, and Group 2 were seniors who chose not to get a flu vaccination shot. After observing the seniors for 10 years, it was observed that seniors who get flu shots are 27% less likely to be hospitalized for pneumonia or influenza and 45% less likely to die from pneumonia or influenza. Do you think that this is an observational study or a designed experiment? This is an observational study. How do we know this? The researchers did not force the seniors to get vaccinated or not, but rather it was the seniors who made the decision to get vaccinated or not. In addition, the researchers did not impose any other conditions on the study. Can you say that all seniors should get a flu shot? Do we conclude that getting a flu shot causes a lower rate of pneumonia or influenza? No, because there are a ton of other existing variables that may impact whether or not one contracts pneumonia or influenza. When you cannot distinguish between the explanatory response variable and some other variable, it is called confounding. We do not know with 100% certainty that getting a flu shot results in a lower rate of influenza or pneumonia because there might be other variables out there that equally impact that particular response variable. That is, contracting pneumonia, influenza, or not. Some of the other variables: the general health of the senior, the individual's genetics, the age of the senior. If it just so happens that all the folks in the non-flu shot group were in their late 80s and all the folks in the flu shot group were in their early 60s, that might have played a role as well. We can go on and on about all the other factors that go into whether one contracts pneumonia or not that are confounding our results because we weren't necessarily able to account for them in the study. Again, confounding in a study occurs when the effects of two or more explanatory variables are not separated. Therefore, any relation that may exist between an explanatory variable and the response variable may be due to some other variable or variables not accounted for in the study. Okay, so the health of the senior was not accounted for, as far as we know in this study, and therefore there may be some confounding. A major source of confounding is the lurking variable. Lurking means hanging out in the background but not really being paid attention to. So, a lurking variable is an explanatory variable that was not considered in the study, but that affects the value of the response variable. For example, the senior could be a health fanatic who probably eats differently and exercises regularly. Or the senior could neglect their health. Maybe they are not exercising as much. Maybe they are not eating the right foods. You just don't know all the lurking variables. Could it be the general health of the seniors contributed to the higher rate of pneumonia or influenza rather than the flu vaccine? Perhaps it was. Some lurking variables in the influenza study are age of the senior, health status of the senior, and mobility of the senior. After accounting for the potential lurking variables, the author of the study concluded that getting an influenza shot is associated with a lower risk of being hospitalized from influenza. The reason the researchers chose the term associated is because in observational studies, we are never allowed to make statements of causality, meaning we cannot say that changes in the explanatory variable caused the changes in the response variable. We can only say changes in the explanatory variable are associated with changes in the response variable. It requires designed experiments to make statements of causality. Observational studies do not allow researchers to claim causation, only association.